Okay, so what we want to do here, this is going to be our last video on variation of functions here. So I just want to kind of let you know how to recognize if this is an inverse variation or is this a direct variation, okay? Well, let's take a look here. Well, we see this graph. Now remember, let's take a look at something. If I say it's a direct variation, that means what? Well, that means this here. X and Y will do the same. Let's just say that. So that means if X increases, Y should also increase. And if X decreases, Y should also decrease. They'll do the same. Inverse means exactly what it is. The end there, X and Y are the inverses of each other. Okay? So X and Y will do the opposite. We'll do the opposite. So if X increases, Y will decrease. Or if X decreases, Y should increase. Okay? This is how we can differentiate between if it's a direct or an inverse variation by looking at a graph at these numbers here, at these at these values here. Okay? Well, let's look here. So let's see. I'll identify this first chart. Well, we see it starts off with these two initial numbers, 4.5 and 8. Okay, so let's see. It goes from 4.5 to 12. Okay, that's an increase. But it goes from 8 to 3. That's a decrease. Okay, let's see. From 12 to 2, that's a decrease. And from 3 to 18, that's an increase. So it looks like they're doing the opposite. Okay, because here we see that X has increased, but and then we see here that Y has decreased. And here we see that X has actually decreased from 12 to 2, but Y has increased from 3 to 18. So this be an inverse. So it would be an inverse. It's an inverse variation, okay? Let's look at this one here. Well, it says 3 and 9, they start off. So 3 goes to 8. Well, that's an increase. And 9 goes to 24. That's an increase. Okay, perfect. Now from 8 to 10, that's an increase. And from 24 to 30, okay, that's also an increase. So they're doing the same. So it'd be a direct. Okay? That's a direct. Hope you guys understand these here because I'm going to give you 2 more example problems, okay? So go ahead and pause the video, write these down, and let's go ahead and get started with 2 more examples. Okay. Let's remember our notes here that we just wrote before. Let's say we have, let's get a chart here. Let's get a chart X and Y. Let's say this here will be 3.75. This here will be 12. This here will be 15. This here will be 3. This here will be 5. I don't know. And this would be, let's just do 5 and 9. Okay? Well, I'm going to actually show you a different way that you can find out if it's an inverse or direct variation in a second here, but let's do it the method that I taught you first. Okay, so let's see. It starts off at 3.75 and 12. Let's see what happens to X. X goes to 15, so that's an increase. But what happens to Y? It goes to 3, so a decrease from 12 to 3. So these are doing the opposite. Right? Now, let's see. What it goes from 15 to 5. That's a decrease, but it goes from 3 to 9. That's an increase. So it seems like they're doing the opposite. So this be my inverse variation. Okay? This be my inverse variation here, right? Okay. Let's look at this graph here. At this table here. And let's see exactly what values we'll get here. Whether it's going to be a direct or inverse variation. So I have X, Y, this, and this. Let's see. Let's take 1. Let's take 0.2. Let's take 40. Let's take 8 and 26 and 5.2. 5.2. Okay, well, it starts off with X is equal to 1 and Y is equal to 0.2. Let's see. X increases to 40. from 1 to 40, that's an increase. Let's see what happens to y. Y increases to 8. Perfect. So these are increases. They're doing the same. And let's see what happens from 40 to 26. Okay, that's a decrease. But 8 goes to 5.2. That's also a decrease. So they're still doing the same thing. At the point that x decreases, y also decreases. Like here, from 40 to 26 and from 8 to 5.2, that's a decrease. But from 1 to 40 and 0.2 to 8, that's an increase. So x and y are both doing the same thing. So this would be a direct variation. So this would be, like we said, a direct variation. It's a direct variation. Okay, let's look at something here. Go ahead and write this down, and I'm going to actually draw your attention to a couple of good points and notes here. Let's go ahead and we'll just start down here. Let's erase this here. Let's say that we're given the direct variation formula. The direct variation which is y is equal to k times x, right? Well, if we're looking at y is equal to k times x, let's solve for k. Because you know k is equal to my constant of variation. So let's find our k value. Well, in order to find k, what we can do here, we can divide both sides by x. Those x's cancel, so then I'm left with k is equal to y divided by x. Perfect. Now that I have this, what can I do with this? K is equal to y divided by x. Well, this will actually tell me what my constant of variation is, or as you may know it, your slope. It'll tell me what my slope is of this, you know, or the rate of change. What is this changing? At what rate is this function here changing, right? So we'll talk about, we'll use this method to actually figure out the constant of variation. And if it follows this rule, k is equal to y divided by x, then that means it'll be a direct variation. Now, what about if I gave you an inverse variation? What happens here? Well, I'm left with, I have y. Inverse variation is equal to y divided k divided by x. Well, solve for k here. We can multiply both sides by x. These x's cancel. I'm left with y. I'm left with x times y is equal to k. Okay, perfect. So if it follows if it follows the rule x times y will get equals k for all of these values here, then it's an inverse variation, right? Okay, so let's go ahead and see what we'll get here. Well, let me see something here. We're looking at, let's use this here. So let's test to see if this really is an inverse variation here. Let's see. In order for the inverse variation, it says x multiplied times y should give you k. Well, let's see. So x, which is 3.75, times y, which is 12, should give me k, if this is an inverse variation. Okay, well, let's see. What is 3.75 times k? I mean, 3.75 times 12. Well, we get 45. So 45 is equal to k. Perfect. Let's see if we get the same k values for these. Okay, so this will be x times y, which will be 15 times 3, which will give me 45. Okay, perfect. That checks out. And last but not least, 9 times 5 should give me k, which is 45 is equal to k. So that also checks out. So what it looks like here, this is indeed an inverse variation because it follows the rule of inverse variations, okay? Let's erase this and try this same function for the direct equation so you can see that it won't work. It won't give us the same answers, okay? Let's try it here. Let's go ahead and see, okay, let's go ahead and take this. Let's take k is equal to y, which is 12, divided by x, which is 3.75. Well, 12 divided by 3.75 gives you a 3.2. So k is equal to 3.2. Okay? But now, look what happens when we do this. So k is equal to, let's try the next one. Let's do 3 divided by 15. Well, 3 divided by 15, that's giving me 0.2. So these, we already see here that these are not the same numbers. So the constant of variation of this function is not the same. So it is not a direct variation because it's not satisfying this here equation. So it has to satisfy this here equation. Every single one of these numbers have to have the same. They have to be changed by the same constant of variation in order for it to be this specific type of variation that for the formula that we used. So that's why it doesn't work for this formula. But when we check it with the inverse variation formula, if we want to figure it out instead of seeing what increases and what decreases, if we take this x and multiply it times y, x and multiply it times y, we should get the same number as if we do 15 times 3 and 5 times 9. These should all get the same number. Okay? Well, let's look at this other graph over here. Let's just see what we'll get over here out of this other graph. Let's just see what we will get. Okay, well, we can do 1 times 0.2. So 0.2 times 1. I'm sorry, let's do 1 times 0.2 because x times y, and we actually get 0.2. Okay, that's good. Let's see 40 times 8. Well, we get 320 if we do 40 times 8. That's not the same numbers I had before. And let's do 26 times 5.2. That's going to give me 135.20. And that's also not the same numbers I had before. So this does not work by this inverse variation formula because it's not an inverse variation. Okay? But let's try it with direct. Well, if we try it here with direct, let's do, let's get a different color here. So k is equal to y, let's say is 0.2 divided by x, which is 1. Well, that's equal to 0.2. Okay, perfect. Let's do k, which is y. Let's find y, which is 8, divided by x, which is 40. Well, let's see what happens when we divide 8 divided by 40. What do we get? We get 0.2. Okay, let's see k. Let's check the last one. So we're checking out here. Let's check the last one. Y divided by x. So 5.2 divided by 26. What do you think that's going to give me? Well, let's see. It'll give me 1/5, which is the same thing as 0.2. So since these are all checking out, that must mean, since all these are being, when I divide these and I'm getting the same constant of variation, then that must mean that it is a direct variation because it checks out for my formula, if you understand what I mean by that. It checks out for my direct variation formula. But it did not, it failed to check out for my inverse variation formula. Okay, so just a quick notes here before we go. And if you want to be able to tell just by looking at the numbers, x and y have to do the same. So let's look here. I mean, x and y have to do the same in order for it to be a direct variation, and x and y have to do the opposite or the inverse for it to be an inverse variation. So let's look at direct. 1 and 2. So starting with these two numbers, did y increase to the second number? I mean, did x increase or did it decrease? Well, it increased to 40. And what happened to 0.2? Y increased from 0.2 to 8. So those are both doing the same. They both increased. Now look what happens from 40 to the next number. So from 40 to 26, that's a decrease. But also 8 to 5.2, that's also a decrease. So they're doing the same. So that's why it's a direct variation. They do the same. X increases, then y increases. X decreases, then y decreases. Okay? Now let's look at inverse variation. They have to do the inverses, the opposites. So we start off with 3.75 and 12. Okay? Well, 3.75 goes to 15. Which is an increase. Well, what happens to y? Y does a decrease. It goes from 12 to 3. That's a decrease. Okay? So it's already doing the opposite, the inverse. So let's go from 15 to 5. That's a decrease. But from 3 to 9. That's an increase. So they're doing the opposite. So this is an inverse variation. And this has been your topic on variation of functions. If you have any questions or anything, any suggested topics or suggested questions that you have, homework topics or anything, please like and subscribe and comment under the videos.